Alrighty, so much of this is going to be review. That's good. And so you know about plotting points, yes?
Yeah.
Which is the horizontal axis, x, which is the vertical axis, y. And something that I never noticed until later is that the arrows are only on the positive end. You look in books, you'll go back and go, oh yeah. Doesn't mean that the positive end is the only end that goes on forever. They go on forever in both directions, right? But it is to indicate which end is positive. Because let's say we had this x and y axis floating in space, then we wouldn't know which way is left, right, up, or down because there's no gravity. But if we have an arrow on the edge side that's positive, we'll still know what's going on. Okay? And then which do we do first? And then y. So we go down here to the left, -3, up 5, and that's point A. You go ahead and do the other points, labeling them letter by letter, and you can discuss it if you'd like to, especially the ones that have a 0. So we go to the right 2, down 4. That's point B. Now, here is what I think happens sometimes with students. When they see a 0, they just ignore it. And so they might go up 5, or for E, they might go to the right 4 because they ignore the 0. Okay? Can't ignore the 0. It tells you which way to go for each number, right? So for C, I go 5 to the right first, and then nowhere up and down. Let me jump to E. I don't go left or right, but I go up 4. Right? So the location of the 0 is important. Don't just ignore it. And then going back to D, I go to the left 5 and down 3. And the easiest one, the origin. Origin means beginning, that's where you start. From there you go left and right, and then up and down, right? Now, what do you think came first? Geometry or algebra? So here's the problem, okay? Here is how math is taught. They start with the equation. And so we make our table. They want us to use integers, so positive and negative whole numbers, starting at -3. Then we plug it in. -3 squared is 9. 4 minus 9 is -5. You fill in the rest of the table. So -2, 0, -1, 0, 1, 2, 3. And so we plot those points, -3, -5, -2, 0, -1, 3, 0, 4, and then a little what's called symmetry, right? The left and right hand sides are mirror images of each other. What goes up must come down. And I missed the points, you'll do better than I did. Now, the fact that we chose these numbers was arbitrary. We could have kept going, and we could have put in the fractions in the middle, which is why we're allowed to fill in and connect the points. We don't just connect the points because your parents wanted to keep you occupied when you were younger and gave you those like 2-inch books with dot to dot. 1, 2, 3, 4, 5. Mickey! Remember that? Now, I'm going to go back to my question. What came first? And I think Euclid was before Descartes. Because here's what happened. Euclid goes, oh, look at that shape. I wonder what that's all about. And so Descartes came along. Can I do this? Let's see if this works. And he took that shape. I guess it doesn't work. I was going to move it onto an XY axis. And if I can move a shape onto an XY axis, then I can have an equation to describe the shape. Shape first, equation second. Because then I can take that equation and then predict where a point's going to be. See what I'm saying? So like in outer space, if you're into astronomy or anything, there's those shapes and orbits already existing. How do we determine where something's going to be? We have to convert that shape into an equation. The equation comes second, even though for your whole life, I'll bet you the equation came first, right? That's why we study this stuff, okay? If you can take a shape and come up with an equation, you're useful. We can use that, okay? If you can just plug into an equation, anybody can do that, right? So, go ahead and do the same thing for example 3. Go ahead and make your table. Same numbers that they want you to start with, but you're going to say, I know there are numbers in between and past the ends. That's why we're going to connect them and draw arrows. Okay, so again, the numbers they want us to try. It'd be very sad if I had to move you back to assigned seeds. So, absolute value is the number, how far the number is from the origin. And so then we get these numbers. And so maybe we could think about this as a pool or billiard table, and the ball bounces, and we have to want an equation to describe the path of the ball, so we can figure out maybe how to do a bank shot or a 3-cushion shot mathematically and never miss. Okay, what a concept, right? Okay, so here we go.